Okay, so in this video we're going to talk about the fourth way to solve a system of equations, and that's using matrices. So I've got a few things at the top that we need to talk about before we go through an example here. First of all, some definitions. We're going to use what's called an augmented matrix when we go to solve a system using a matrix, and that is just a matrix that represents a system of equations. So that'll be our first step. We'll write an augmented matrix, which is pretty easy to do. The second definition is what's called reduced row echelon form, and the best way to describe that is if you just look at how the left part of this looks. This is what I want. I want my leading term to be a 1, and I want to go for the first row. I want my first term to be a 1. The second row, I want my second term to be a 1. And my third row, I want my third term to be a 1. That's what I want, and I want everything else over here to be a 0. Okay, so that's what we call reduced row echelon form. These are all 1s, everything else is a 0, and then my last column are where I'm going to have some different numbers going on. Okay, and then the third definition is what's called Gauss-Jordan elimination, and that's just the process of solving a system of equations where I get reduced row echelon form on this left side. And I solve this in order to get my system of equations, the answer to my system of equations. Okay, so then when we solve a matrix using this idea of Gauss-Jordan elimination, we've got three things that we can do. Okay, so we want to keep these in mind as we work through this, and I know that right now we don't know what that means at all, but the three things that I can do, I can add a multiple of one row to another, I can multiply a row by a non-zero constant, and I can interchange two rows. And using just those three operations, I'm going to be able to get this left side to look the way that I want it to look. Okay, so always keep that in mind. So the first thing I'm going to do to solve this system, which, remember, and I didn't talk about this on the other video over systems, it is possible that I have a system of equations that is more than two equations. Remember, basically, however many unknown variables you have, you need at least that many equations to solve for those variables. So in this case, I have three unknowns, which means I need three equations. You did a lot of this in Algebra 2 when you solved a system of three equations with three variables. So the first thing I'm going to do is I'm going to write out the augmented matrix. So the way this is going to look is I am going to basically just write the coefficients straight across. So my first row is going to be 4, 8, -4, and then 4. And then I'm going to do the same thing here, 3, 8, 5, and -11. And then -2, 1, 12, and -17. So that's what we call an augmented matrix. That's really easy to do. Sometimes, not all the time, but sometimes you'll see a line before that last column, and that's just nice because we can see then the left side clearly and how we want the left side to end up looking. So my suggestion is that you always start with this top left corner, and remember, we want that to be a 1. Okay, so how can I make this 4 become a 1? And what I would do to do that is I'm just going to do 1/4 of row 1. 1/4 of row 1 will give me a 1 there. I'm just going to divide that whole row by 4. So my first step, and I'm just going to work straight across here. My first step is I'm just going to replace row 1 with 1/4 of row 1, which means this is 1, 2, -1, and then 1. And then the other rows, I haven't done anything with those yet, so 3, 8, 5, -11, and -2, 1, 12, and -17. Okay, so that was my first thing that I wanted to do. The next thing is, once I have this, what I want it to be, I want this to be a 1, I would work down that first column, and I want both of these things to be a 0. So how can I make this become a 0, and how can I make this become a 0? And remember, I've got these three things that I can do. I can multiply by a non-zero constant, but the problem with that is there's no way I'm going to make this become a 0 by multiplying by something that is non-zero. Same thing with this. So I'm not going to be able to do that. Simply interchanging two rows isn't going to help, but this is what's going to help. Add a multiple of one row to another. So basically what I want to do for this next step is I am going to do, I'm going to add a multiple of row 1 to each one of these rows and then replace those rows. So I'm going to replace, and this is kind of how I can write this out, I'm going to replace row 2 with -3 times row 1, right? If I take row 2 and I'm going to add to that, I'm going to add to row 2 -3 times row 1, and that's going to give me row 2. Okay, so if I take row 1, I multiply by -3, I add that to row 2, and then replace row 2 with that. That's what I'm going to do there. And then similarly, I'm going to take row 3, and I'm going to add to that 2 times row 1, and then I'm going to replace row 3 with that. Okay, so row 3 plus 2 times row 1, that's going to give me a 0 here. So in doing that, my top row, I'm not going to replace it. I'm going to use it to replace these other ones, but I'm not replacing it at all. So here's what you want to think about. If I take -3 times row 1 and I add it to this, so -3 times 1 would be -3, add to that, that gives me a 0, which is what I wanted there. -3 times 2 is going to give me -6. Add that to the 8. That's going to give me a 2. -3 times -1 will give me a 3. Add that to the 5. That's going to give me an 8. And -3 times the 1 will be -3. Add that to -11. That's going to give me -14. And then doing the same thing for row 3. I'm just going to take twice row 1 and add it, so that's going to give me a 0 here. 2 times 2, 4, add that to the 1 will give me a 5. 2 times -1 will give me -2, add it to the 12 will give me a 10. And 2 times 1 plus the -17 will give me a -15. Okay, so I've already got 3 numbers the way I want them. I want a 1, a 0, and a 0. Okay, the next thing I would do then is I would take the next row down, and I want this to be a 1. Okay, I want this to be a 1, and in order to do that, I'm just going to replace row 2 with 1/2 of row 2. Just like I did 1/4 of row 1, if I do 1/2 of row 2, that's going to make that a 1. So that next change is going to be easy. The top row, still 1, 2, -1, 1. If I replace row 2 with 1/2 of row 2, that's going to make that a 1. That's going to be a 4. This is going to be a -7. And this is a 0, a 5, 10, and -15. Okay. We've got that to be a 1, so we're good there. So just like what I did with this step, I'm going to do the same thing in order to get this 5 to be a 0. I'm going to use this second row to make that happen. So I'm going to do I'm going to take row 3, and I'm going to add to that -5 times row 2, and I'm going to replace row 3. Okay, so row 3 plus -5 times row 2, replace row 3. Top row stays the same. 1, 2, -1, 1. Middle row stays the same. 0, 1, 4, -7. And bottom row, this is still going to be 0. If I do -5 times 1 and add it to the 5, that's going to give me a 0 there. -5 times the 4 will give me -20, and add it to the 10, that's going to give me -10. And -5 times -7 will be 35, add it to the -15 will be 20. Okay, Almost got it. I want this to be a 1, right? So I'm going to multiply this by negative, I'm going to replace row 3 with negative 1/10 row 3. I'm basically just going to divide by negative 10 if that's the way you want to think about it. That's going to give me, so now I have 1, 2, negative 1, and 1. I have 0, 1, 4, and negative 7. And I have 0, 0, 1, and negative 2. Okay, I'm going to pause for just a second. This is what we call, not reduced row echelon form, but we call this row echelon form. And row echelon form means these three numbers don't have to be zeros. I have 1 across the diagonal here. These bottom numbers are 0. I can possibly stop here because what I want you to know is that if you have it in reduced row echelon form, if you have this 1, 0, 0, 0, 1, 0, and 0, 0, 1, then my solutions to the system are these numbers in that order, x, y, z. So I have, at this point in time, I know that z is equal to negative 2 because I have this part going on for that bottom row. However, because I don't have these as zeros, I can't say what x and y are. But if I do know that z is negative 2, I could use that fact and go back and substitute in negative 2 for my z values and figure out what x and y would be. But I'm going to keep on going just so I get it in reduced row echelon form. It's really not that hard to work backwards from here. But once you get into row echelon form doing that process, the rest of this is pretty easy. What I would want to do next is I'm going to replace row 2 with, I'm going to do, take row 2, add to that negative 4 times row 3, and then replace row 2, right? And so that makes sense because if I take negative 4 times this and I add that to row 2, then that's going to make that a 0. So in doing so, this is still 1, 2, negative 1, and 1. Bottom row, I'm not going to change that, so 0, 0, 1, negative 2. In the middle row, if I add negative 4 times row 3 to that, this is still going to be 0. This is still going to be 1. This is now going to be, see, negative 4, yeah, that's now going to be 0, because I'm going to do negative 4 times 1 and add it to 4. And then I'm going to do negative 4 times negative 2, which would be 8, and I add that to the negative 7, and that's going to be a positive 1. So at that point in time, I now have what I want for row 2, and now I just need to get row 1 where that needs to be. So there are a couple of things that I can do here. It's really going to take me a couple of steps from this point. I need to make both of these zeros, and I'm going to have to do it a step at a time. One thing that I can do is I can just take row 1 and add row 3 and then replace row 1. So that's going to make this become a 0. Just add that. So in doing that, this will be 1, 2, 0, and negative 1, because I need to make sure that I add the negative 2 and the 1. Didn't mess with row 2. Row 3, 0, 0, 1, negative 2. And then my last step would be I need to make this 2 become a 0. So I'm going to take negative 2, row 2, add that to row 1, and replace row 1. And so in doing that, bottom row still the same, 0, 0, 1, negative 2. Middle row still the same, 0, 1, 0, 1. And the top row is going to be 1, negative 2 times this and add it to it, that's 0. This is still 0. Negative 2 times 1 is negative 2. Add that to the negative 1 and I get negative 3. And so that tells me, now that I finally have it in reduced row echelon form, that my solution, my x, y, z solution is negative 3, 1, negative 2. So keep in mind that is where a system of 3 equations in 3 variables will meet. They meet at that point, -3, 1, -2, as an ordered triplet. You could do this idea of using a matrix to solve a system of linear equations, like two linear equations, and I could solve for x and y doing the same exact thing. If you use, and I can show you how to do this on a calculator, it's really useful on the old like TI-84 calculators to do this. But if you remember reduced row echelon form, this is always just my x, y, z, or however many equations I have, solution. So that's the idea of using a matrix to solve. I know it was kind of a long process, but I do want you to be aware of that because you're going to see this in advanced level mathematics courses. Especially if you ever take a linear algebra class, you'll do a lot with matrices, and so it's kind of nice to know what those elementary operations and all of that, how those apply to solving a system.